All right, good morning or good afternoon, and welcome to lesson 5 of module 1. Today we're going to be learning about negative exponents and what we do to simplify those. Let's go ahead and get started. All right, jumping right into it, we're going to get into our rule. So basically, the rule is whenever you have a negative exponent, it's the same as writing it. We can change it to a positive exponent by just putting a 1 over top of it, turning it into a fraction. Right, and maybe that doesn't make sense to you, but I'll show you again right here with a number. Please write this number down. So say we have 5 to the negative third power. We want to turn that negative exponent into a positive exponent. Basically, all we're going to do is we are going to put a 1 on top and put it on the bottom and write it positive. Okay? So again, all we have to do is flip this over, write it as a fraction, and then our negative exponent disappears. I'll do another one down below. So you have 3 to the negative second power. You should know that there's an invisible 1 underneath this, so all we're going to do is we're going to flip this upside down. Now I'm going to put the 1 on top, make this a fraction, and instead of saying 3 to the negative 2, it now becomes 3 to the positive second power. So this is what we are going to be doing today. Additionally, if you ever get a number that says like 1 to the 3 to the negative fourth power, this is the same as just flipping it over and putting it as a positive exponent on top. The same as saying 3 to the fourth power over 1, which we know is just 3 to the fourth power. All right, we will continue this practice on the next slide. Let's go ahead and move forward. All right, for this first question, it says, verify the general statement that x to the negative power is the same as 1 over x to that positive power for x equals 3 and b equals negative 5. So it says turn your x into a 3, so this becomes 3, and turn your b into a negative 5 to the negative fifth power. So how would we write this? Well, the first thing we should know, there's an invisible 1 underneath. To turn that exponent positive, we're just going to flip this upside down, put the 1 on top now, and then our exponent becomes positive 5. Okay? Move it on to example number 2. All right, example number 2, what is the value of 3 times 10 to the negative second power? Well, what we're going to do is we're going to take 10 to the negative second power and actually write that as a positive exponent. Okay? So we're going to flip this upside down, so a 1's going to go on top, 10 to the positive second power is going to go on the bottom, and we're still multiplying this by 3, right? So it's 3 times 10 to the second power. To simplify this even further, we're actually going to multiply this out. So when we multiply fractions, we multiply it across. 3 times 1 is 3. And 1 times 10 to the second power is just going to stay 10 to the second power. So this is our answer simplified. All right, go ahead and make sure you have that down. Let me know if you have any questions about it. We're moving to example number 3. All right, example number 3, what is the value of 3 times 10 to the negative fifth? So the first thing I want to do is turn this into a positive exponent. I do this by flipping it over. Right now it's 10 to the negative fifth over 1, and changes to 1 over 10 to the positive fifth. I just flipped it and changed my exponent to positive. This 3 stays the same, and this is the same as 3 over 1. And I'm multiplying these both across. 3 times 1 equals 3. 1 times 10 to the fifth equals 10 to the fifth. So that is my final answer here. All right, continuing on to example number 4. I've actually decided we're going to skip example 4 for today. You will learn about this on Thursday probably. Okay, moving on. All right, here is a recap of our new learning for today. When a number is raised to a negative exponent, so we have 5 to the negative second power, we can write it as a fraction. So it would be 5 to the negative second power over 1. And then we can flip it when we turn that 1 into our numerator position, and we will make our exponent positive. So we flip it over and make it positive. This would be 1 over 5 to the second. I'm going to give you another example down here that I want you to do with me. Let's do x to the negative third power. First thing I'm going to do is I'm going to write this as a fraction. Second thing I'm going to do, I'm going to flip that fraction upside down, and then I'm going to change this to a positive exponent. All right? So those are our two examples there. Make sure you have them down, and we're going to get into some exercises now. All right, here's the first set of exercises. Basically, it just says for exercises 5 through 10, write an equivalent expression in exponential notation to the one given and simplify as much as possible. So we might be combining some of the rules we've learned together today, or learned previously together with what we've learned today. I want you to go ahead and take 5 minutes to work on this, and then we will go over it and review the answers in 5 minutes. If you don't know the answer, I want you to do your best guess. Try your hardest, okay? And then we'll go over them. All right, for exercise 5, first thing I'm going to do is I'm going to write this as a fraction so that I can flip it. I want to turn that negative exponent into a positive exponent, so this is the same as 1 over 5 to the third power. For exercise 6, I want to flip this around. I'm basically working backwards. This is the same as, if I were to flip it over upside down, it would be 8 to the negative 9th over 1, which is just the same as 8 to the negative 9th power. Okay, just changing these up. For exercise 7, my 3 is going to stay the same. And then this 2 to the negative 4th, I'm going to flip it upside down. It's going to be 1 over 2 to the positive 4th. And then I can actually multiply this out. 3 times 1 is 3. 1 times 2 to the 4th is 2 to the 4th. So that's my final answer there. Number 9 says let x be a non-zero number. We're just going to rewrite this as a fraction and then flip it upside down, making our exponent positive, 1 over x to the third. Okay. Exercise 10, we're going to work backwards. It's already been changed to a positive, so we're going to change it back to a negative. So we would just flip this upside down, change our exponent to negative, and then anything over 1 is just itself. So this is x to the negative 9th power. Okay. And then lastly, exercise 10, let x, y be two non-zero numbers. So the first thing I want you to notice is that x and y are different. The negative 4 is only attached to my y. Okay, so the x stays the same. So the first thing I'm going to do is I'm going to change my y to the negative 4th to have a positive exponent. So this is the same as 1 over y to the positive 4th. And this x didn't change at all. It just stayed as an x. There's an invisible 1 underneath it though. Then I can multiply these across. X times 1 is just x. 1 times y to the 4th is just y to the 4th. That's my final answer there. Go ahead and check these, and please let me know if you have any questions about what I've done here. Yeah. Hopefully it's not too difficult for you. We're just, changing things, the way that things look based on their negative or non-negative exponent and simplifying them. Let's go ahead and move on to the next set of exercises. All right, our next set of exercises, we are actually going to be combining some things we've already learned. So for exercise 11, we're dividing. And we have the same base, the base of 19. So it's going to stay my base of 19. All we're going to do is subtract our exponents. 2 take away 5. Well, 2 take away 5 is negative 3. So I have 19 to the negative third power. Could I change this so it has a positive exponent? Yeah, I flip it upside down. I write it as 1 over 19 to the positive third power. All right. For exercise 12, I want you to try this one. Again, we are dividing. We have the same base. So you're going to keep that base, and then you're going to subtract your exponents. Tell me what you get. All right, you should have found that your base stays the same, 17, and then we're doing 16 minus negative 3. 16 minus negative 3 is a double negative, and it changes to plus positive, which becomes to the 19th power. So 17 to the 19th power is our answer here. Exercise 13. Go ahead and cross this one off. We're going to skip exercise 13. Moving straight into 14, it says show directly that 7 over 5 to the negative fourth is the same as 7 to the negative fourth over 5 to the negative fourth. Well, we can show this because if we have 7 over 5 and we're raising this to the negative fourth power, then we are going to distribute this negative 4 to both of the terms within our expression. So that's why this becomes 7 to the negative fourth times over 5 to the negative fourth. From there, we can simplify this even further. All we want to do to change those to both positives is flip it. So this becomes 5 to the positive fourth over 7 to the positive fourth. And now we have two positive exponents instead of two negative exponents, and it looks a lot more simple for us to do. All right, let me know if you're having any questions with this. But we're pretty much done here. We're going to move into our closure and then our exit ticket. All right, as a reminder, our lesson for today, if we have some numbers raised to a negative exponent, first thing you want to do is make sure that you remember that that negative exponent only goes to the one number it is beside. If there's no parentheses, it is only going to this 5. So this is the same as saying a times 5 to the negative third. Okay? From there, we want to change our negative exponent to a positive. We would just flip it over and write it as positive. So this becomes a times 1 over 5 to the third. All right. And if you wanted to simplify that further, a times 1 is a, and 5 to the third just stays the same. All right, so there is an example for you. I'll do one more example off to the side. 1 to the negative second. This is the same as 1 over 1 to the positive second. We just flip it over. Okay? Maybe I'll do one more. 5 to the negative 8th power. We know that there's an invisible 1 underneath this, and so we just flip it upside down and change it to a positive 8. Okay, so that is our lesson summary for today. That is how you turn negative exponents into positive exponents, and you can also work backwards and do the same thing the other way. So for example, if I had 1 over 5 to the fourth, this is the same as 5 to the negative fourth. Okay, because we just flipped it over and changed our exponent to a negative. Let's go ahead and look at our exit ticket for today. All right, here's your exponent. The first thing you're going to do is just simplify, or the only thing you're going to do here is just simplify these exponents that are negative by rewriting them as positive, or vice versa. So for the first one, you have 7, 6, 5, 4, 3 to the negative fourth. In Galileo, you're going to simplify that by removing that negative sign and doing some changes. Same thing here, except it is a variable. Over here, you're going to do the same thing. This is when we're multiplying a number times another number written with a negative exponent. You have a couple examples like this. This is when we're doing the same thing but with variables. And this is one that is written as a fraction that has a negative exponent on the bottom. How will we turn that to a positive exponent? What will we do? So remember to look back at your notes if you need help. Rewatch some of the lesson video if you're really struggling on your exit ticket. And then when you're finished, make sure you get your lesson reflection done as well. Post it in Google Classroom.